All right, recording now. Okay, so I want to start off by talking about ease. And I think before Ryan started talking, I heard somebody mention Richicke. And so I'm talking about ease in the Richicke sense, where you have these two axes that things can be easy to use. One is where you already know how to use it, and that's what ease is. The opposite is that it's like unfamiliar to you. The other axis is simple versus complex, or what he calls complected. So I'm specifically talking about things that are familiar to you. So PureScript is sort of by definition right now targeting JavaScript developers, since it targets JavaScript as its foreign language that it compiles to. And it's already using a different paradigm and syntax than JavaScript. So why should we make things any harder for people that are jumping from JavaScript to PureScript? We want to make it very easy for them to make that transition. And so to that end, if we look at addition, which normally you think of numbers, but also in JavaScript, you can add strings together and it works the same as string concatenation. If you try to do that in PureScript, when you pull in the regular prelude, it doesn't work. We're going to get that error that says, hey, string's not a semi-ring. And at this point, you're probably going to go Google that message and somebody will say, oh, you have to use append or plus plus or the diamond operator. And you probably don't understand what a semi-ring is. So I feel like this is friction that doesn't really need to exist. You can implement addition with strings in PureScript. It's pretty simple. And actually, that's what I've done in Neon. So if you import Neon, you can add strings together. It works exactly the same as it does in JavaScript, and hopefully exactly like you would expect. So I have a list of principles on the README for Neon, which are things that I try to adhere to, and that's sort of what I'm running through now. And ease is the first one, and what it boils down to really is that if something is possible in JavaScript and it's not a terrible idea, then you should probably be able to do it in Neon without too much fuss. That's not to say that Neon is just going to do exactly what JavaScript does. There's definitely some warts in JavaScript that I don't want to repeat. So one of them, for example, is that you can add a number to a string, and it'll stringify that number for you and then tack it onto your string. And to me, it's very useful to be able to catch those types of, not necessarily errors, but it's not exactly clear what you want to do in that situation. Like, you should explicitly convert that number into a string before trying to concatenate them together. So in Neon, even though you can add strings together, you can't add a number onto a string. So you still get type safety. I'm not throwing that out the window. The next thing that I want to talk about is pipes, specifically like functional pipelines, which most developers are more familiar with as Unix pipes. So like cat sum file, pipe it into grep, pipe it into sort, pipe it into unique. These aren't necessarily going to be familiar to JavaScript developers because there's nothing built into JavaScript that deals with pipes. Like, you can write imperative stuff, but you can't write pipelines very easily without pulling in some extra libraries. So instead of using JavaScript as an example here, I'm going to use Elixir. F# also would have worked. Elm actually also would have worked. Maybe that's what I should have gone with given the content of Ryan's talk. But really the idea here is that you start with some value and then you pipe it through transformations until you end up with the thing that you want. So here I have a list of lists of ints, and then I flatten it so that it's just one list of ints, and then I want to take the length of that thing. So to do that in PureScript with the normal libraries, the core libraries, you have to pull in control bind and data array. And so you use join, which is a monadic operation, to concat these lists together, or flatten them rather. And then you use length from data.array, which is monomorphic, to figure out how long that thing is. And there's a ton of other ways to do this using stuff from the prelude. So you can use the $sign operator to remove parentheses if you want to. You can use the hash operator to remove parentheses in the other direction if you want to do that. You can also use the triple greater or triple less operators to define new functions that are just compositions of these other functions and then apply those to your value. In certain circumstances, these are all really good things, but I'm not a particular fan of any of these operators, or really methods of developing. So the thing that I've given in Neon is a operator called colon, which works a lot like pipe forward in Elm and Elixir and F#. So I take this array of arrays, and then I use colon to pipe it into this flatten function, and then pipe it into my size function. And the reason I went for colon over pipe forward is that I didn't also want to support pipe backwards. I think that piping forward is the only direction that really makes sense. It would have been easy to use pipe forward and then also supply pipe backward, but then at every junction, you'd have to decide which one you wanted to use. So I opted for only providing the colon and only, providing one direction for your program to flow in, left to right. I also went with colon because it's sort of similar to like dot syntax and object-oriented. So if you had some array, you could do dot flatten dot size. I would love to be able to use the actual dot operator for this, but PureScript currently doesn't allow that. I know there's an open issue for it. And I know that it's very difficult because dot is already overloaded for module names, like this module name dot some function that I've imported from it, and also field access on records. So some record dot some field. Adding a third thing, which is, hey, just some random operator, that's going to be challenging. So in order to support piping for every function in Neon, I put the subject last. So what I mean by that is like the thing that you're operating on should be your last argument. So that way, if it's in a pipeline, you'll supply all of the other arguments, and the thing you're working on will come from the previous step. So it'll be like object colon some function and some args, and then your object will get tacked on to the end. And the reason I went with this is because in Haskell, I realized that every time I used the map library, I loved working with it because the map was always the very last thing that you would pass, like the last argument to these functions. So it would take like, all of the things that vary, like if you wanted to look up some value in a map, the first argument would be the key and the last argument would be the map. So that way, if you were doing a chain of operations, you'd start with your map and then pipe it into lookup with the key, and then pipe that into like, from maybe with your default value. And so you didn't have to use flip or throw in any lambdas or anything like that. You just had to keep piping, and your object, or the thing you're working on, would flow through. Also, by doing this, you give things an object-oriented feel, which some people might perceive as negative, but I feel like the subject-verb way of talking about things is very natural. So you have this thing that you're working on and these actions that you want to take on that thing. Another note about this is that I didn't provide an operator for function composition. Just like the pipe backwards operator, it would be pretty easy to give that. In fact, the one that PureScript provides, the triple less than or triple greater than, I think are very great. Way better than Haskell's dot for function composition, which doesn't really give you indication in which way things are going. The reason I didn't provide one in Neon is that I, unlike Ryan, unfortunately, I'm not a fan of writing things in the point-free manner. I really like having all of your arguments explicitly listed out. You can look at the type signature for a function and the argument list and match each argument up to a type, and it makes a lot of sense, at least to me. I do see the beauty and oftentimes like utility in if you're just renaming something, just say like this thing equals this other thing, and you don't have to list out all the arguments. But for things like, sum is going to be a fold over the list of things starting with 0 using addition. There's no real harm in passing that extra argument in there. You have to give it a name, but that's not too big a problem. So yeah, and let's see. In normal PureScript using the standard libraries, you could define the function we were looking at on the last slide to be point-free, not mention any of its arguments. In Neon, that would be harder because the only thing I provide is this colon operator to pipe arguments through. Yeah, I see a comment here. It does kind of look like a Ruby symbol. It's a little bit unfortunate. I actually program in Ruby for my day job, so maybe it was a unconscious or subconscious decision on my part. Next thing I want to talk about, which Ryan actually touched on a little bit, is documentation. I think we can all probably agree that in the Haskell ecosystem, the documentation leaves a little bit to be desired. Plenty of people seem to think that the type signature is a good substitute for documentation, or maybe they think that it's sufficient. And in a lot of cases, I think that's not true. It can be a great addition, a good supplement to actual documentation. But if you load up the documentation page for some module and it's like this function with this type of signature, this other function with this other type signature, 9 times out of 10, for me at least, I'm just going to go right back out and not even use that library. And if I have to, then I'm going to be angry about it, because I want to know, what is this library used for? Like, why did you write this thing? You didn't just do it for fun, probably. And like, show me some concrete examples. So to pick on the Prelude a little bit, the documentation in the Prelude for the most part is very good. The functor one in particular isn't that great, which is why I pulled it out. But what it says about functor is that it's a type constructor which supports a mapping operation, which is good if you already know what mapping is. If you don't, then you're out of luck, because it's saying that it can turn functions from A to B into functions from f of A to f of B, which I understand what that means, but if you're not already familiar with functors, that doesn't tell you a lot. And then it also gives you the laws, which again can be useful if you already understand what a functor is, or if you're trying to write your own instance. But like, nobody's going to say, what's a functor? And then look at these laws and say, oh, I understand completely. No, it's too abstract. You need something concrete, at least at first, to understand what this thing is. So in Neon, the documentation is actually for a different class called hasMap. I don't have a class called functor, but hasMap is roughly equivalent. And it represents types that can be mapped over. And then I also mentioned that this is known as a functor, so that if you want to go look it up somewhere else, you can do that. And then in the documentation, I give a concrete monomorphic example of using map, which is the only class member for this type class on a concrete data type. So like, hey, if you have an array, you can use a map to work on each element of that array. I still think that this could be better, and I would like to give examples for every instance, so also for maybe and lists and that kind of thing. But another improvement I would like to see is what Ryan mentioned about the Elm documentation, using a more conversational style and giving like reasons for why this thing even exists. Like, why do you care about mapping? So my punchy quote for this is that everything should be documented with examples, and specifically monomorphic examples, not like let X equal some container of things and let F equal some function, then this would be F map or X map F. That's not useful to anybody. So the next part I want to talk about is probably the most contentious aspect of Neon, and it has to do with laws. In Haskell and in PureScript, it's generally considered good practice to avoid lawless type classes. There are several reasons for that, but I don't really want to get into them right now. I just want to point out that you don't have to look very far to find lawless type classes, even in the prelude of either PureScript or Haskell. The show type class, for instance, has no laws. It has some implied laws if you combine it with the read type class in Haskell, but those are a little iffy at best. Similarly, you don't have to look far to find instances that don't obey the laws. So you have the ORD type class, and there is a float instance for that, but it's not law-abiding. And everybody mostly seems to be okay with that. Or if they're not okay with it, then they recognize that it's hard to fix. So one aspect, or one thing that falls out from this is that you can't use the or double pipe operator to take the logical union of lists or arrays, actually. So, and this is because the type class that OR is in has laws that it has to abide by, and you can't abide by those laws with arrays, so you can't provide an instance for it, or you shouldn't provide an instance for it. In Neon, I feel like if you have some list and some other list and you want to combine them with the double pipe, most people are going to know what that means. And again, you can do this in JavaScript, so I feel like you should be able to do it in PureScript because most people will be able to figure out what it is. The problem with this is that trying to come up with laws that are are applicable to both arrays and Booleans, such that you get results where you can do this with arrays and you can do the normal thing with Booleans, is really hard. I haven't been able to do it. I think that it can be done. There's, I forget the guy's name, but there's a great library for Haskell called Subhask, which tries to build up very useful abstractions, but also grounded in laws. So if you are interested in the ideas that I'm talking about here with Neon, but want a more like solid mathematical lawful foundation for them, you should go check out Subhask because it is amazing and incredible. So my takeaway here is that laws should not prohibit useful instances. I'm not anti-laws. I think that they're a good way to allow users of type classes to know what to expect and allow library maintainers to know what to write their instances to do. Also, it's really useful to check your instances with quick check, and those basically just check laws. And I see in the comments that I might be wrong about how Node handles the double pipe on arrays, so I need to go check that and make sure that I'm doing the right thing. So the next thing I want to talk about is the type class hierarchy. This was actually a big deal recently in Haskell because they changed applicative to be a superclass of monad, and previously that wasn't the case. So now it is. Now pure means the same thing as return, and everybody's happy, I guess. In Neon, none of my type classes have any hierarchy, so nothing is a subclass of anything else. Everything is a la carte. Like if you want to bind things, monadically bind things together, there's a type class for that. If you want to use applicative pure, there's a type class for that. If you want to do both, you have to ask for both. And just an example here, so picking on functor, the whole hierarchy again, you have apply, which is a functor is a superclass of apply, and then you can have some function where you require some container that is apply and the element in there, and then you do something with that. In Neon, I have two classes, one called hasMap, which as we saw before is the same as functor, and then hasApply, which is the same as apply. And if you want both of those things in your function, you have to ask for both in your type signature. If you only needed apply, or if you only needed map, you could ask for one of those. And the reason I'm okay with this, even though like having apply by itself doesn't make a lot of sense without map, is that you can rebuild the hierarchy if you want to, given each of these pieces is discrete. So if you have map, that is just synonymous with functor. And then if you want to build up the old apply class, you can do that by specifying both functor and hasApply as your superclass. And then same thing with applicative, same thing with monad. Like you can build this hierarchy back up if you need that rigor, or if you don't want to be so wordy all the time in all of your type signatures. So my takeaway is that there should be no type class hierarchy. I do have one exception to that now, which is I added a compare class. And its superclasses are the type classes that provide equality, less than, and greater than. And I did that because I feel like it wouldn't make any sense to have compare, return equal, but not implement the equal type class. And you could argue that having pure but not providing apply also doesn't make any sense. And you may be right. I don't actually know enough category theory or whatever it is to have an answer to that. But so far it's worked out well for me. I would love to have some feedback on this because it's pretty weird.
Can you explain the eq one a little more? Eq versus ord?
Yeah. So in Neon, I broke ord up into three type classes, one that's roughly equivalent to eq, and then I have a separate type class that provides greater than and a separate type class that provides less than. So if you want to provide something that's like ord, you have to do three different type classes, equal, greater, and less. And then on top of that, if you want to say that my data type represents a total ordering, like every element or every element of this data type can be compared against every other element, then you have to also provide an instance for this compare class, and that has its superclasses are eq, greater, and less. So you have to provide those three as well. But then you get this additional compare one, which returns the typical ordering thing back to you. Does that make sense?
Sounds good.
Okay.
One thing that I'd like to add to that, like the compositional type class thingy, is I think it could work out positively in terms of performance, because I know that super classes involve some very deep dictionary passing.
That would be a nice win, but that's definitely not why I did it.
Yeah, using type classes for a lot of things is not a performance win anywhere right now.
Right. I'm unfortunately aware of that. All right, moving on to operators. PureScript allows anyone to define pretty much any operator they want to, with a couple notable exceptions, like you can't do dot, as I mentioned earlier. And a lot of people do. You don't have to look far in Pursuit to find a bunch of operators. And I think for certain use cases, operators do help things. So like if you want to write your own operator for joining file paths together, that can make your code read a lot cleaner than having some function that you jam between all of these things. But in general, I feel like having too many operators is a problem. So even on that slide I showed a while ago, where I had like the $ operator and the hash operator and the triple less than and the triple greater than, that's a lot of operators for somebody who's not familiar with PureScript to encounter all at once. And as an example of this, I love to pick on the lens library in Haskell because it has so many operators. This one actually only shows one of the operators that it defines, the percent tilde. I feel like anybody looking at this who doesn't already understand the lens library just has no hope of understanding what it does. There's a lot of operators. There's 3 operators there in addition to some syntax, and there's a lot to unpack. So I feel like for libraries that I write, I don't want to encourage writing code that looks like this. I would rather have a bunch of functions that are easier to search for. I know you can search for functions in Google or Heyu or Pursuit or whatever, but for me, typically my first stop when I find code that I don't understand is to Google for language name plus thing that I don't understand, and that's where operators fall down. So in Neon, this is every operator that Neon provides. It's almost exactly the same as JavaScript with 2 notable exceptions. The first is that exponentiation is with caret instead of star star. Star star actually isn't in JavaScript yet, but it will be soon. So I might switch power over to using that. And then also the addition of colon for this reverse function application. So not a lot to worry about here. If you've programmed in any like C-style language, JavaScript included, you'll know what all of these do already. You'll notice that I use bang equals instead of divide equals for not equal. I don't understand why Haskell and friends go with the slash equal. Well, I do understand, but I don't agree. So yeah, I think there should be as few operators as possible to make reading and learning about code easier. It's a lot easier to say, oh, what is this map function than what is this less than $ greater than sign function. That's a lot harder to look up. Next thing I want to talk about is there's more than one way to do it, which is what this awful acronym stands for. Some people pronounce it Tim Toady, but it's the unofficial motto of Perl. And it's one that I'm not very fond of. I'm a lot more fond of Python, which says there should be one obvious way to do things. So to pick on the prelude again, it provides pure and return as 2 functions, which are the same thing. And I understand why return is provided. And I also know that it is going away, which I'm very happy about. But this argument could be said of Haskell as well. Return is provided because if you're writing something that works monadically, and the very last statement in that thing is a pure whatever, it looks really good to say return because it almost just looks imperative. You have whatever equals do a bunch of stuff, return something. But it doesn't make sense when you know that you can just add another line after that return and keep doing stuff. And it doesn't short circuit there. It doesn't actually return. It just like injects this value into a monadic context. So in Neon, I don't provide that. I think that pure is a better name. So that's the one that I use, and I just don't provide return. And in general, I feel like aliases are sort of a cop-out. Like you should pick one way to do something and then just do that. People will get used to it. They'll understand what it means. And like I said, I stole this from the Zen of Python. There should be one obvious way to do it. Sort of late in the presentation here, but talking about type classes, they're the primary means of abstraction in PureScript. And so I feel like in order to allow program and library maintainers to use my functions with their data types, everything I do should be in a type class. If I write just some monomorphic function that only works on data types I know about, you're screwed, you can't use it. You have to convert your stuff into what the function expects, then call the function and then convert it back out again. So that's why I like using type classes. As a sort of motivating example, it's pretty easy to write monomorphic things. So like if you wanted to add two integers together, you can do that. You can add two numbers together as separate classes, but then you always have to either refer to these things by their full names or like import them qualified. And I'm not very happy with either of those approaches. So throw that thing in a type class and then use your monomorphic versions as the instances. I feel like the only real downside of this is that the error messages are not as good. So like we saw with the semi-ring error message, like if you try to add two things together and they're not instances of this class, you're going to say, hey, this data type isn't an instance of this class, rather than you gave me a string and I wanted an int. And I don't have a solution for that. I know that in the most recent release of GHC, you can provide custom error messages, which is really nice. I don't know how that applies here or if it applies, but it could be
so Phil chimed in earlier that, and he also mentioned, I don't remember whose presentation it was, but the presentation of programmable type errors, and that those like are high priority for PureScript.
That would be awesome. I don't know how to write those myself, but I will learn, because making the error messages better when your type classes don't line up would be awesome. So yeah, the short takeaway for me is that functions should be defined in type classes. One sort of fringe benefit of this is that if you write a function that works on a type class, you can know more about that function because what it does is limited. Like if you write a function that takes an int and returns an int, or so let's say it takes two ints and returns another int, that function can do anything. But if you write a function that takes any two things that can be added and returns some other thing, there's only like 3 or 4 things that function can do. And I think this is the propositions as types talk by Wadler, but regardless, it's useful when just looking at the type signature, you can pretty much figure out what a function is going to do. And follow on that, I like the type classes in Neon to be as small as possible. So for instance, the bounded type class in the Prelude has 2 members, bottom and top. And I feel like that's good because you can define some laws about that, especially when you combine it with an ORed instance and say like, okay, bottom has to be less than everything else and top has to be greater than everything else. But by splitting them up, you can define even more instances. So a lot of types have a bottom, but they don't have a top. So pretty much any container type is going to have a bottom, and it's going to be the empty container. But it won't have a top because there is no, set that contains all sets. There is an empty set, and that'll be your bottom. So you can provide that instance, and then you can use it wherever you want to, and you don't have to bother with the top instance or provide like a bogus one. And I feel sort of justified in this because the bounded type class to begin with doesn't have any laws, so splitting it up, you're not really losing anything. So yeah.
Yeah. Sorry, may I chime in here?
Yeah, go ahead.
Yeah, so you earlier said that there should only be one very obvious way to do it.
Mm-hmm.
Now, if I want to get at the empty set, I could use the bottom set, or I could use mempty or whatever you have for appendable as the empty element.
Yep, I call it 0, and that's an unfortunate overlap that I don't have a resolution for. But yeah, I feel like that's the common argument when you say there should be one way to do things. It's very easy to point out situations where there are multiple ways to do things, because you can look at the same data type under different, I was going to say lenses, but it's perhaps overloaded, different like contexts. So like yeah, a list can have a bottom, which is the thing that's less than everything else, or it can have an empty, which is the thing that doesn't contain anything. And they happen to be the same thing in this case, but they're discrete concepts. So that's my way of reasoning out of that particular trap.
Okay. Well, I would say the thing is, if you used the list as the empty element and you were appending to it, the compiler would infer that you meant the monoid instance. Whereas, right? So that's where the type class, by putting these methods together, helps the inference tell you what kind of empty list you wanted in this case.
That's true. If you did like 0 plus some, the same thing with Neon, the compiler would infer that you need the 0 class and the add class. And then if you switched it to be bottom, it would assume that you need that one instead, which would be wrong, I guess. Like, it doesn't make sense to add stuff to the bottom, but it's a potential shortcoming of the way I'm doing things. Haven't really explored it yet. I'll need to, though. That's a good comment. Thank you. So the next most contentious part of Neon after laws is naming. And we sort of touched this already when you try to add something and it says, hey, that's not a semi-ring. And I think that any JavaScript developer seeing that will say, okay, what's a semi-ring? Similarly, if you try to map over something that isn't mappable, it'll say, hey, that's not a functor. And you'll say, okay, what's a functor? In Neon, if you try to do this, you get a thing that says that thing doesn't have the map function. So you should go implement that. You can go Google for functor, which I'm going to get at here. So Edward K. always says that these names are good, and his argument is that you get access to 70 years worth of documentation. My counter argument is if you go to Wikipedia and search for functor, it says a functor is a type of mapping between categories, which is applied in category theory. It can be thought of as homomorphisms between categories. And I don't know about you, but that doesn't turn on any light bulbs for me. The rest of the Wikipedia article isn't much better than the introduction there, but some people might get something out of that. I know that I don't. So I feel like having a name that is useful for a concrete example, even if it's not always accurate, is more useful and helps understand. It's easier, at least for me, to look at the map thing and say, oh, this maps over containers. And then even in an instance where that's not strictly accurate, I can say, okay, but like in general, that's what it does. In this particular case, it's not correct. Versus saying, oh, well, it's a functor, and that's generally correct because it's only defined in terms of this operation, but doesn't really give you any intuition about how the thing works. So this is similar to the split between with default and from maybe, where with default, if it's applied to any container, not just maybes, may not make sense in every instance, but like the from maybe method, of course, always makes sense because it's tied to the data type.
And I think just to build on that, if you don't mind.
Yeah, go ahead.
So one of the biggest, well, I don't know, I don't want to call it a problem, but one of the biggest barriers I see with naming is, so yes, I can Google functor, but reading that Wikipedia article, now I need to Google category theory and monomorphisms, and like it leads to more questions. And what I would like to see is to defer those questions in favor of getting stuff done. Like, and it's the same discussion with laws. Like, laws matter for parametricity; they're helpful. But it would be nice to defer that until, there's a context for understanding why it matters. And then just one more thing is that like Haskell is surprisingly inconsistent about naming. And so, yeah, they pick mathy names for things like functor and monad, but then they pick English names for their operations like map or bind. And if you look at things like, even Kmet, who's building lens, he names functions things like zoom. And so I'm never going to actually be zooming around with my lens, but like he tries to build a metaphor. And what I heard, I don't remember, it's one of the Scala guys, but he said, you know what, names is like a hook to hang my hat. And so it's a place just to begin building. an idea. And my problem with not particularly functor, but some of the other names is that when I do forget what they mean, I don't have something concrete to fall on. It's kind of like a circular definition. So
Mm-hmm. Yeah, the one I love is monoid, which is like something that has an operation and has an identity element, which isn't terribly useful. But like if you forget what it means, you're not going to have any luck going back or remembering again when you remember that it's called a monoid.
or when you learn that functor means something different in other MLs.
Yes. Very frustrating. Yeah, so moving on from there to totality. PureScript obviously encourages safety through the type system, and it's not as guilty of this as Haskell is. The Haskell standard library is pretty awful at providing you a bunch of functions that have type signatures that look harmless and then they explode, like head and tail, I think, yeah. So those are the classic example, but the one I went with here is toenum, which takes some integer and converts it into some type that is enumerated. So it just blows up if you give it a number that's outside the range of things. So in Neon, I solve this by if the thing isn't total, return a maybe. And then if you want to throw caution to the wind and convert that thing, you can use with default or like from just if you wanted to go that far. But yeah, so in general, pure functions shouldn't throw exceptions. If they're going to throw an exception intentionally, prefix that thing with unsafe and then go nuts, do whatever you want. And I feel like this is especially important since you can't catch exceptions from pure functions. You can only catch exceptions inside IO or F or whatever. So it's like, hey, I made this thing in a pure function that you can't deal with in pure functions. Good luck with that. The next thing I want to talk about, which is a common problem for me, especially in PureScript, is imports. I feel like they're getting better, but one of the problems is that things in PureScript are very fine-grained. So I took this import list from an actual program that I wrote that just like made a web request, parsed some JSON, and made a decision about it, and then sent another web request back out. So pretty simple, something you could do in like Python or Ruby with 1 or 2 lines of imports. I don't know how many it would take in JavaScript, but a few, I guess. But yeah, you end up with like literally more than a page of just imports. And this is something I wanted to avoid for libraries that I wrote. So with Neon, you just say import Neon and you're done. If for whatever reason you don't want to do that, like you are writing a DSL and you don't want to collide with any names that I might have defined, the other way to do it is to import Neon qualified and then import the operators unqualified. Since I have so few operators, they're all defined in one module. So A, that makes documentation a little easier because that's the one place you need to go to look to see what operators there are. And B, you can pull in everything qualified and then just the operators unqualified because qualified operators are the worst thing in the world and I hate them.
One question.
Yeah, go ahead.
Does that turn out with that code elimination? I'm not sure how the algorithm is, but does that mean I always pull the entire Neon when I use PSC bundle?
I'm sorry.
Do I need to go back to the fine-grained imports with that code elimination for my code?
Ooh, that's a good question. I don't know.
Could from use functions because that's one of the major benefits of the fine granular that you get a lot smaller bundles than say with Elm.
Right. I don't know. I actually haven't looked into much of the performance stuff that I'm doing with Neon. I'm kind of just writing it the way that I want it to look. And then after the fact, I'm going to go in and see how it performs. So it could be that this is suboptimal and you'd be better off importing each thing individually so that you don't pull in as much, but I don't know. All right, so that's all that I have. If anybody has any questions, I'll be happy to answer them. I see that there's some comments in here. Yeah, so one thing I kind of want to address in general is that there's going to be some internal inconsistencies here with the things that I'm saying. Like, yes, some of the things that I argue for good naming, and some of the names that I use aren't that intention revealing, especially things that are really hard to name without leaning on something super abstract. So Pure is a good example. I've tried to come up with a better name for Pure because really, typically when you use Pure, you're dealing with impurity. Like you're trying to inject a pure value into an impure context if you're, some pure value and you're working in the F monad. And I wanted to call it wrap, but I didn't go with that because wrap implies that you can unwrap it. And in general, you can't unwrap it. Like you're injecting this thing into a context. And then I thought, well, we could use inject, but inject collides with the Smalltalk / Ruby select, detect, inject, reject family of functions. So I didn't go with that either. But if anybody has suggestions for how to solve these inconsistencies, I'm definitely all ears. I want Neon to be better. Trying my best here.
Man, that's pretty awesome. So are you using this in any other projects yet?
I am not. I actually don't use PureScript for anything, so this is kind of just a curiosity for me. I would love to, but at my day job, I do Ruby and Clojure, and in my free time, I do mostly Haskell, so there's not a lot of room left for PureScript, unfortunately.
Rewrite your point-free website in PureScript?
I've thought about it. That would be nice, but it's so small. I mean, I feel like I wouldn't learn that much.
Yeah.
Sorry, I just moved my laptop so I can get this damn thing charging. Do you mind if I interject with a couple of questions?
No, please go ahead.
Cool. So it's kind of a double-barreled one. So they're both one of the intention of Neon, and secondly, a more sort of specific implementation kind of question.
Okay.
So one, is it intended as a sort of a learning library, as in like a teaching library, sorry, or something that's sorry, there's a conjunction with the second part, but it feels like it's going to end up with a parallel version of PureScript, basically.
Mm-hmm.
Basically, because the interop between the two different pieces is going to be rather hard, mostly because of the orphans thing. I've got a library A, which is from the PureScript universe, as in, shall we call it PureScript Prime
Sure.
and PureScript
I know what you mean.
So we have something from, basically like a library already exists or whatever, and we have Neon. And because of the no orphans rule, suddenly we don't have the ability to map between them, like with the type classes, for example.
Right.
And so we need to either make a PR to Neon to support this other library, or we need to go to that little thing to support Neon. And suddenly we end up with, unless we're very careful, like parallel universes. So I wasn't really sure what your intention with Neon was. I wasn't sure if it was teaching or things to use in the application, or we don't mind. Like I saw your thing has a, like, maybe you're thinking of designing basically almost your own language with it,
mm-hmm.
or something. Anyway, sorry, I'm going to stop asking a question now.
Yeah, hopefully I can. Initially, I started Neon just as an experimentation on like, what would it look like if everything was in a type class? And this is sort of where I have ended up. But my intention now is to have it sort of as a parallel prelude / standard library. So I agree that the orphan instance problem is a legitimate, real problem that is very hard to solve. And the two ways I see to solve it are either keep Neon as small as possible and convince a bunch of people to use it, and then everybody will build on top of that. But I don't see that happening. The prelude is fine as it is. Neon isn't compelling enough to convince most people to switch. The other way to go is to recommend only using Neon for applications where you can wrap your things in new types if you need to, and then just deal with those, which isn't great. Obviously, wrapping and unwrapping new types all the time is annoying, but it's really the only solution in PureScript since you can't have orphan instances at all. Like, there's no escape hatch. So yeah, it's a little subpar. One thing I actually did in the earlier versions of Neon, like last year, was that I defined all my own data types because I was like, okay, what would it be like to basically build my whole language, or whole standard library rather, up from nothing? And it was a good learning experience, but at the end of it, I realized nobody's going to use this thing if every time they have to interact with it, they have to convert all their data types from what they know and love into my little version and then back out again. So I ditched the data types, but kept the type classes, and it's sort of the happy medium for me. Like if you're going to say that you can't use type classes in my, or I can't define type classes in my library because orphan instances, then I can't really do anything in my library other than provide monomorphic functions. So I feel like it's a problem just intrinsic in writing a separate standard library.
Yeah, cool. All right, thanks, and good talk.
Thank you. Hope
So,
that answers your question.
I haven't seen the actual issue for it, but I have seen Phil mention several times chained instances. So I think this is something on the near future roadmap. And I don't know what it means, but supposedly it's some kind of somehow resolves our orphan instance problem.
That'd be cool. I actually just ran into a variant of this problem today because I was looking at adding sets to Neon because I have arrays and lists and I want to have sets because I feel like they're a good handy data type. And it's very hard because all of the functions that deal with sets have an ORD constraint on them. So I'm going to have to figure out how to convert my comparison hierarchy into the Prelude's ORD hierarchy and then make it all work together.
How far, and I haven't thought very far through it, but how far does just creating implicit instances for things like functor? So like where there's an implicit has map. Wait, am I saying this right? So if you have a has map, you have a functor. I mean, I guess it requires that your APIs accept functor, right?
Yeah. I haven't looked into doing that yet, but it would be really nice because there is intentionally a lot of overlap. Like when I was looking at the classes I wanted to implement in Neon, I just ran through the list of them in the Prelude. And so I could say, yeah, like if you need a functor, I can provide one with this other instance or vice versa. But I don't know how to do that or if it's possible.
Right. Well, I've definitely done the instance thing where I'm trying to think what I did it for. I created a constable when I was exploring that problem space.
Okay.
And I was able to create, like if I built up my constable, these implicit instances for other things to support functions that had additional constraints. So I mean, I didn't hit any walls with it personally, but I haven't seen it, you know, I don't do a lot of Haskell, so I haven't seen it in any other code.
All right.
So if I wanted to use like the product monoid in the system, basically I'd make a new type and then define add as being multiplication on that new type.
Yes. Unfortunately, that's how it would look. There is a multiply type class, so that's the one you would probably use.
But if I was using like a generic thing that just accepted basically monoids without calling them monoids,
yes,
it would probably accept it as add.
Yes, that's correct. So that's one of the downsides of not adhering to any laws is that really I only have the names to work off of. So if you're adding things together, but you choose your add instance to actually be multiplication, then it stops making sense.
That's where I felt like, and I don't know, subjective, just the way I learned. I feel like looking at lists for inspiration is the most helpful for me. Because typically, for me, it just gave me a basis for understanding how it applies to other types because it encompasses the idea of none or one or many. Or even, in a sense, either, because it's either none or some. And so in that case, you'd have append, I think, or what would you call it? Concat or whatever.
I mean, it's
concat,
add,
I guess.
but yeah.
Yeah, right.
And lists, I believe, are the free monoid. Is that correct? Maybe that's kind of why it makes sense there.
I don't know.
Yeah, I've heard that, but I didn't deeply understand it. I read about it. Cool. Well, thanks, everybody. I'm going to cut off the recording. You're welcome to hang out and chat. If you are